Hi, I'm Lauren.
And I'm Denise, and in this segment of Principles of Human Movement 101, the first portion we will be outlining are the basics of collinear versus concurrent forces.
Baby steps first. Both collinear and concurrent forces are known as vectors, which is defined by their size/magnitude or length, as well as their direction or orientation.
Now we can get to the fun stuff. First up is collinear forces. These are forces that are parallel to each other, meaning they act in the same line. These can go in the same or opposite direction of each other as well.
Next up is concurrent forces, which are forces that don't act in the same direction but do act through the same point.
The way to calculate these forces, there are two different techniques used. For collinear forces, you use addition when they are going in the same direction and subtraction when they are going in the opposite direction. Similar to the concept of tug of war, where you combine the same directions with each other and take the sum. Direction is important.
Now, when it comes to adding concurrent forces, it gets a little bit more complicated, but don't fret. To calculate this type of force, the Pythagorean theorem is used, which is a squared plus b squared equals c squared, in case you forgot. And the resultant, or sum, is c squared.
After coming up with the totals of both the concurrent and collinear forces, you can calculate the net force. This is the total sum of all the forces combined.
In this first example, we will be showing how collinear forces work on acting on a stalled car, with the forces, or the two men, in our example, pushing the car from the back.
As you saw in that example, it was very easy to move the car because of the forces moving together. In this next example, we will be showing you how concurrent forces work on moving a stalled car in comparison. You will notice that it was much more difficult to move the car because the two forces, meaning again, the two men, are not moving in the same direction.
As shown here.
Hi, my name is Kiana.
I'm Sierra, and in this portion of the segment, you will be learning about distance and displacement. Distance is the length of a path followed by an object from initial to final position. It is known as a scalar quantity. A scalar quantity can be fully described by their amount or magnitude. For example, distance, time, and position.
Displacement is the straight line distance in a specific direction from an initial to final position. Unlike distance, displacement is known as a vector quantity, which is size and direction specific, as stated before. You can find displacement by subtracting the final position from the initial position. For example, if I ran a 400-meter race, what is my displacement?
As you ponder that question, let's take a look at an example for both distance and displacement, that of a super track athlete running a 400-meter sprint. Wow, that was impressive, don't you think?
Yes.
So as you saw in the clip, the length she started and finished from was a total of 400 meters. So this gives you the total distance from the start to the final.
So if you guys can figure out my question from before, I'll go ahead and explain. My displacement would equal 0 because I finished in the same place where I started. 0, the final position, minus 0, the initial position, equals 0, the displacement.
Thank you guys. That was this segment on distance and displacement.